First of all, we want to again verify that the point pi over 4 and pi over 2 is on the graph of this one, and then we're going to find the tangent in the normal line at that point. Okay, so let's do the verification process. So x value pi over 4 times the sine of 2 times pi over 2 needs to equal pi over 2 times the cosine of 2 times pi over 4. Okay, so pi over 4 times the sine of pi needs to equal pi over 2 times the cosine of pi over 2. Well, the x value at pi over 2, all of that right there is 0. The sine value at pi is 0. So, yep, it's looking like 0 equals 0. So we can check that off. And going to now our meatier part of this, let's go about finding the derivative. Okay, so we've got chains happening on both the left and the right, or the product rule, because it's going to be x times the sine of 2y is equal to y times the cosine of 2x. So here's the derivative then. So it's going to be first times the derivative of the second. So the derivative of sine is cosine 2y, and then times the derivative of the angle, which is 2, plus the second. Oh, just 1 second. We forgot something, didn't I? Coming back in here. What's that angle? I got ahead of myself. That angle right there is 2y. So the derivative of 2y is 2 dy dx. Got going a little fast, didn't I? Okay, so first times the derivative of the second. Derivative of sine 2y is cosine 2y times the derivative of the angle, which is 2 dy dx. Okay, and then plus the second times the derivative of the first, which is just 1. Okay, that's going to equal, now first times the derivative of the second, and the derivative of cosine 2x is negative sine 2x, times the derivative of the angle, which is just 2, because it's just x. So first times the derivative of the second, plus the second, times the derivative of the first, and the derivative of y is just dy dx. Okay, so let's clean this up just a little bit more. So that's my main function there. We have 2x times the cosine of 2y, and then dy dx, plus the sine of 2y is equal to, looks like negative 2y times the sine of 2x plus the cosine of 2x dy dx. Okay, so let's isolate our dy dx's. So let's move this term over, and we're going to move that term over that way. So if I factor off also what's connected to dy dx, then minus cosine of 2x dy dx is going to equal negative 2y sine of 2x minus sine of 2y. Okay. Now wrapping this all up just so we can get our derivative equation, you'll get dy dx is equal to negative 2y sine of 2x minus sine of 2y, all divided by that bracket. So 2x cosine of 2y minus the cosine of 2x. Okay, so there's our equation that we're going to use to help us find the derivative. And then from there, we're going to plug in our points, specifically at pi over 4 and pi over 2, and then find our tangent lines and normal lines. So let's go ahead and find that derivative, by the way. So dy dx evaluated at pi over 4, pi over 2. Okay. You know what? I'm thinking I'm going to run out of room. So if y'all don't mind, I'm going to kind of erase some of my work up above, and then I'm going to leave my derivative just sitting right down in here, and then we're going to come back and finish out the rest of the problem. Just 1 second. Okay, so dy dx evaluated at our coordinate. It's going to be negative 2 times our y value, so pi over 2, times the sine of 2 times our x value, so I'm just going to go ahead and write that as pi over 2, minus sine of 2 times our y value, which is going to be, 2 times pi over 2, which is just going to be pi in there. So let me go and do that. All divided by, so 2 times x, which is going to be pi over 2, times the cosine of 2 times y, which is pi, minus the cosine of 2 times x, which is pi over 2. Alright, so let's go back into our trig and actually solve this out. What is the sine of pi over 2? Well, the y value there at pi over 2 is 1, and then the y value at pi is 0, so that's going to go away. So there in the top, we're just going to get negative 2 times pi over 2, which is negative pi, times 1, which is negative pi. Okay, and the slope down here, the cosine at pi is negative 1, so it's going to give me a negative pi over 2, and then the cosine value at pi over 2, that right there is 0, so it's just that. Okay, so let's finish solving this up. So pi, negative pi, times negative 2 over pi, those cancel off. A negative times a negative is positive, so our slope is 2, specifically at those 2 points. Okay, 2 things. We got to find the tangent line, and then we're going to find the normal line. So the tangent line is always the parallel line, so it always uses the exact same slope. And then we have our point, pi over 4 and pi over 2. So y minus the y value is equal to our slope times x minus the x value. So y is equal to 2x, and if we have 2 times negative pi over 4, it's a negative pi over 2 plus a pi over 2, and those cancel off, so we just get that for our answer for the tangent line. For the normal line, we use a perpendicular slope. So now it's going to be negative 1/2, still the same point, still y minus the y value, only difference here is a different slope. Okay, so we're going to get y is equal to negative 1/2 x, or negative x over 2. Negative 1/2 times pi over 4 will be a positive pi over 8, and pi over 8, I'm going to have to do some math here, plus pi over 2, it's going to be, looks like 5 pi over 8, so plus 5 pi over 8 for a y-intercept, but that right there, so that's going to be the normal line, and that's going to be the tangent line, both linear equations. Alright, and that calls us finished for this lesson.